Hello everyone and welcome. In this video, I will demonstrate a prototype of an SAP SuccessFactors Multi-Agent network. The purpose of this project is to provide employees, HR teams, and HRS professionals with a safer and more controlled way to ask questions about SuccessFactors data. Instead of allowing one general AI agent to access everything, this solution uses multiple specialized agents. Each agent has a clearly defined responsibility and can use only approved read only tools. At the center of the network is the HR Orchestrator. It receives the user's question, understands the request, and decides which specialist agents should be involved. The four specialist agents are Employee Central, Position Management, Data Quality, and Security Review. The current prototype uses synthetic SuccessFactors style data so it can be demonstrated without access to a real SAP SuccessFactors tenant. It is implemented locally using the OpenAI agent's SDK runner and 11 read only MCP tools. The most important design principle is this: the AI agents can decide how to coordinate approved capabilities, but they cannot decide who the user is, which employees the user may access, or which fields are safe to display. Those decisions remain under deterministic application control. Let us look at a typical demonstration question. A user asks for employee 1004, show the current job and assigned position, validate the assignment, and check the result for restricted data. This appears to be one question, but it actually contains several separate HR tasks. First, the employee central agent retrieves the employee's current job information and manager relationship. Second, the position management agent retrieves the assigned position, its status, and the incumbent information. Third, the data quality agent performs deterministic validation. For example, it can check whether the employee's job assignment is consistent with the assigned position. Finally, the security review agent checks the proposed response for possible restricted data exposure. The HR orchestrator coordinates these activities and combines the permitted evidence into one grounded answer. This demonstrates an important benefit of the multi agent pattern. The user does not need to know which success factors, entity, API, or technical tool should be used. The user asks a normal business question, and the orchestrator divides it into bounded specialist tasks. However, the specialists do not receive unrestricted access. Each specialist can only use the MCP tools assigned to its role. The result is a conversational experience with controlled, explainable, and auditable execution. This slide presents the architecture of the solution. At the top is the user experience layer implemented through Streamlit. The interface collects the question, the effective date, and the demonstration identity. It also displays the final answer, tool activity, lifecycle trace, token usage, and estimated cost. The next layer is the FastAPI application. FastAPI creates the session and correlation context, applies request level policies, and selects the appropriate runtime mode. The orchestration layer uses the OpenAI agent's SDK runner. The runner starts the HR orchestrator and applies limits such as maximum turns and maximum output tokens. These controls prevent unnecessarily long or unbounded agent activity. Below the orchestrator are the four specialist agents: Employee Central, Position Management, Data Quality, and Security Review. The FastMCP layer publishes 11 typed read only tools. It also applies dynamic tool filtering so that every specialist sees only the tools that it is permitted to use. Below MCP is the HR tool service. This is one of the most important security components in the architecture. It verifies authorization, applies employee population restrictions, limits results, removes prohibited fields, and records safe audit information. The final layer is the typed data provider. The prototype currently uses a synthetic mock provider. However, the provider interface creates a controlled integration point for a future SuccessFactors OData V2 connection. This separation is important because the orchestration model can evolve without weakening the underlying authorization and data access controls. Now let us follow the runtime process from beginning to end. Step 1 is context creation. The application identifies the user and creates the role, session ID, correlation ID, and effective date context outside the model prompt. Step 2 is routing. The HR orchestrator analyzes the question and selects the specialist agents needed to complete the request. Step 3 is tool filtering. Each specialist receives only its approved MCP tools. For example, the employee central agent cannot access unrestricted position management operations, and the security review agent has no direct HR data retrieval tools. Step 4 is authorization. Before any provider call is executed, the HR tool service verifies whether the current user is authorized to access the requested employee population. Step 5 is sanitization and audit. Denied fields and unknown properties are removed from the provider response. The application then records safe audit metadata, including the correlation ID, role, tool name, result count, outcome, duration, and source. The complete HR payload is not written into the audit log. Step 6 is synthesis. The specialists return bounded evidence to the HR orchestrator. The orchestrator combines this evidence and produces one final answer for the user. The system also provides a safe operational trace. It can show agent names, tool lifecycle events, token usage, and estimated cost. However, it does not expose complete prompts, private reasoning, tool arguments, tool outputs, or sensitive HR data. Security is not dependent only on the quality of the AI prompt. The solution uses a deterministic control plane that remains authoritative even if the model makes an inappropriate tool selection. First, identity is application controlled. The user ID and role are passed through protected HTTP headers. They are not accepted as model generated tool arguments. Second, employee population access is controlled by server owned allow lists. An agent cannot increase the number of employees that a user is authorized to access. Third, field level security removes restricted and unknown properties. For example, the synthetic dataset includes national identification records for security testing, but the national ID field remains denied, and no retrieval tool exposes it to the agents. Fourth, the application applies injection resistance, request to change identity, disclose credentials, reveal prohibited data, generate raw data URLs, or perform write operations are rejected. Fifth, tracing is designed to avoid capturing sensitive content. Only safe lifecycle metadata is recorded. Finally, every permitted tool call creates an audit event containing operational information without storing the complete HR payload. The security review agent provides an additional review layer, but it is not the primary security boundary. The primary boundary is the deterministic application control implemented below the model. It is also important to clarify that this prototype is read only. It cannot hire, terminate, transfer, promote, update compensation, or modify a success factors record. Now we will see how these four agents, employee central agent, position agent, data quality agent, and security agents are invoked when we are asking the different type of questions. So let's ask the first question. What is the department of this employee? And you can see that it has returned the department is D100. The tools which it has used is employee central specialist, and under that it has used get employee job information. And you can see the delegation trace also, how the tool has started with HR orchestrator agent, it has gone to the agent employee central specialist, then the tool call within the agent is get employee job information, then it has been transferred to the HR orchestrator agent. Let's ask the next question, which is more for the position. So let's see how many active positions are there. Let's see what it answers. So it says there are 50 active positions, and in this case it has used the position management specialist, and the tool which it has used is count position. You can see the delegation trace also. Here it is, the position management specialist is called, and then the tool is called count positions. Let's go to the next question. Which employees have overlapping job records? So here you can see that it is given that the employee who have overlapping job records are employee ID E1002 and E1003. They both have multiple job records that overlaps in effective dates. And here if you see, the tools used is the data quality specialist and the validate employee population. So it is like the same way, it has called the data quality specialist, and then within the data quality it has called the tool which is validate employee information, and it is passed to the HR orchestrator uh, agent. Now the last question is, I am asking about the security, which is uh, the national ID. It should not display the national ID because I have given the instructions not to share any confidential information. So see, it has say the request was rejected because it asked for the prohibited data or attempts to alter the application security boundary. And the tool which is used is basically it security review. So it is came under the security review and it has rejected the uh, request itself. The prototype has now been implemented and verified locally. The current test baseline includes 34 passing automated tests. These tests cover schemas, authorization, population scope, field sanitization, OData escaping, MCP tool permissions, API responses, effective dating, compound agent flows, and cost calculations. The solution exposes 11 typed read only MCP tools across 4 bounded specialist agents. Most importantly, it exposes zero write operations. The next stage would be a small controlled success factors test and pilot. Thank you for watching.